Hi, good to see you again. Welcome to Block 2, Developing Geometric Reasoning, Lesson 5. I'll share my screen. So, in your previous lesson, you learned how to apply knowledge of a geometric fact that the sum of the angles in a triangle is 180 degrees. And you use that fact to solve interesting maths problems. In today's lesson, you're going to know and apply the fact that the sum of angles in a quadrilateral is 360 degrees, and you're going to use that fact to solve interesting maths problems. Remember to like the video, subscribe to the channel, and click on the notification bell so that when new videos are released, you will be notified. Share the video with those you think can benefit. By doing so, you help us grow our mission to provide a platform where children around the world, regardless of their economic circumstance, can have access to high quality maths education. Thank you. Before we start, I would like you to pause the video and answer the retrieval practice questions in 3 minutes. You can take shorter or longer. You can work at your own pace. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. Here, for the first question, you were asked to write down the size of angles A, B, and C. We can see the angle notation here represents the right angle notation. So that is 90 degrees. Now, if that is 90 degrees and you see these hatch marks here, it means B and C must be equal. Now, if we use our triangle knowledge, we know that 180 minus 90 degrees is 90 degrees. So we have 90 degrees left for B and C to share. Now, if B and C have to be equal, it means B and C should be 45 degrees each. For question 2, you were asked to write the mathematical name of each shape. Now, here you can see for shape A, the shape has a pair of parallel sides, so that is a trapezium. For B, that is a rectangle. For C, you can see that this shape has two pairs of parallel sides, so this is a parallelogram. And for this shape D, although it wants to look like a parallelogram, but it has all four sides to be equal, so we call this a rhombus. Let's do some new learning for today's lesson. We'll look at quadrilateral. The word quad comes from the Latin word meaning four. Lateral would mean sides or lines, so quadrilaterals refer to four-sided shapes, and here they are. All right, so four-sided polygons are called quadrilaterals. Let's start to look at some of the properties of quadrilaterals. Look at these two shapes. What's the same and what's different? Well, you can notice that it has all four sides to be equal. So the left side, the shape on the left side has all four sides to be equal. But this one has two different pairs of parallel sides. Okay, so two different pairs of sides that are equal. So opposite sides are equal. So not parallel sides, sorry. Two pairs of sides that are equal. So this side is equal to that side, and that side is equal to that side. It has four right angles. So those are the same properties. So that one has four right angles as well. Let's explore this shape a lot more. So we know this is a square. It has 90 degrees at each of the vertices. If we put those 90-degree angles together, what do you notice? Well, if we investigate the amount of turn all those angles put together would take, we would see that it is 360 degrees. So let's investigate that again. 360 degrees. So 4 lots of 90 degrees is equal to 360 degrees. So we can confidently say that in this quadrilateral, which is a square, we have 4 lots of 90 degrees, which is 360 degrees. What about this one? Well, if we were to chop the angles off and we put them together in a vertex, all the vertices put together, and we investigate the turn, we would see that it's still 360 degrees. So for this quadrilateral, which is a parallelogram, we see that we still form 360 degrees. Let's investigate another fact. So look at this table carefully. We've wrote number of sides of polygon, name of the polygon, and the sum of the interior angles. This is the first fact we learned in our previous lesson. Let's add to this table of facts. In fact, in the future, you would see this table again, and we're going to add some more facts to it when we investigate other polygons. But this time, we're going to add an extra fact for 4 sides. Well, looking at this triangle, that establishes the first fact. So 3 sides, which a triangle has, the sum of the interior angles is 180 degrees. Imagine that we take another triangle and we place it on the side or adjacent to this triangle. Notice that on the other side we have 90 degrees. This here is 45 degrees. And of course, these other parts should be 45 degrees as well. Well, 45 degrees at 45 degrees is 90 degrees. So we have 4 lots of 90 degrees, which is 360 degrees. So we can add another fact to our table stating that 4-sided polygons, which name is quadrilaterals, the sum of the interior angles is 360 degrees. So, one fact we must establish in our geometric reasoning lessons is that the interior angles in a quadrilateral sum to 360 degrees. It's now time for you to pause the video and practice what you've learned. So what you've learned so far is that the sum of the interior angles in a quadrilateral is 360 degrees. Quadrilaterals are 4-sided shapes. Pause the video and answer questions 1 and 2 in 3 minutes. Assuming you've paused the video and you've answered questions 1 and 2, here are the answers. Let's discuss them. For question 1, you were asked, here are some quadrilaterals. For A, for each quadrilateral, choose one vertex and join it to each other vertex in the shape using straight lines. This will split each quadrilateral into triangles. And this is what you could have done. Next, you were asked, how many triangles has each quadrilateral been split into? Of course, 2. Next, for B, you were asked, what is the sum of the angles in a triangle? That's 180 degrees. And next, you were asked, complete the sentence. Angles in a quadrilateral sum to 360 degrees. For question 2, Jack is working out the sum of the interior angles of a parallelogram. Here, Jack says, I have split the parallelogram into 4 triangles. 4 times 180 degrees equals 720. So the angles in a parallelogram sum to 720 degrees. Of course, we disagree with Jack. Why? We know that the triangles, the quadrilateral can only be split into two parts. This is not how to split it into those number of parts. And we've just learned that the sum of the angles in a quadrilateral, of which this parallelogram is 360 degrees. Okay, let's do some further learning. Here is another example for the second part of our lesson. Looking at this quadrilateral, if we measure this angle using our protractor, by now you should know how to use a protractor. If you don't, please go and watch our previous lessons where we have learned how to use the protractor. So we position the crosshair of the protractor at the point where we want to measure the angle. We make sure the line 0, either using the interior or the external scale, but in this case we're using the interior scale to line up with the line from which we'll be measuring our angle. We'll see that that is 40 degrees. If we measure this angle, we'll see that this angle is 140 degrees. So now we're using the outside scale. You can see it lines up with this line, lines up with the 0 mark of the protractor. We'll see that the angle is 140 degrees. If we measure the other part, so we flip the protractor upside down and we measure that part, we'll see that it is 140 degrees. If we measure the other angle, we'll see that it is 40 degrees. What do you notice about the angles? Well, I'm sure a smart bunch has noticed that the opposite angles are equal. So one other fact you want to learn on your geometric reasoning bag of facts is that opposite angles of any quadrilateral are equal. So opposite angles of a quadrilateral are equal. Using that fact, how would we calculate the size of angle X? Have a think. Well, we know that we have just learned a fact that opposite angles of a quadrilateral are equal. So this angle has to be 110 degrees. Now, if that angle is 110 degrees, therefore, the other angle has to be X. They are opposite angles. So we have enough information now to form our equation. So we're going to put our equation solving skill to good use. Now, remember the fact that the sum of angles in a quadrilateral is 360 degrees. So we can begin to write this. So 110 degrees. Sorry. So we know this fact. Now, x add x is 2x. 110 plus 110 is 220 degrees. Now, putting our equation solving skill to good use, we can say to make the x stand on its own, we have to eliminate the thing that is immediately preventing us from doing that. So we subtract 220 degrees from both sides. So remember, whatever you do to one side of the equation, you have to do it to the other side. So 2x will be equal to 140 degrees. Now, the next step is to make sure we have x standing on its own. And the thing that is preventing us is the 2 multiplying the x. So we have to divide by 2. That cancels out. X will be 70 degrees. So using our equation solving skills, we can solve this problem using our equation solving skill and the facts that we have learned about quadrilaterals, we can solve this problem, which could have looked like a complex maths problem. And that gives us our answer. How would you solve this problem? Have a think. Well, we know that these marks represent 90-degree marks. Okay, so they're 90-degree notation. So we can form our equation to solve this problem. So we can say, again, x add 105 degrees, add 90 degrees, add 90 degrees will be equal to 360 degrees. X, when we add 90 plus 105, that will be 180, add 105, that will be 295 degrees. Yeah, sorry, 285 degrees. Again, applying your equation solving skills, we subtract 285 degrees from both sides. So x will be 75 degrees. You could also solve this using your bar model reasoning, but I really want you to make use of your equation solving skills. All right, so you can see the bar model, using the bar model, how to think about it using the bar model. Everything will add up to 360. So all the other bars added up is 285. So to get x, you do 360 minus 285 degrees. So it's the same approach, but I want you to get used to using the equation solving skills. It's now time for you to practice what you've learned. Pause the video and answer question 3 in 2 minutes. Assuming you've paused the video and you've answered question 3, here are the answers. Let's discuss them. For question 3a, you were asked to work out A and B. You were asked to work out the unknown angle in each trapezium. You know these are 90 degrees angles, so I'm just going to write the solutions, and then you can use a calculator to check that the answers are actually what they are. So here we know the equation you would form will be A, add 90 degrees, add 90 degrees, add 63 degrees, equal to 360 degrees. Now you have A, add 90 plus 90, which is 180, plus 63. That will be 243 degrees. So A, add 243 degrees, equals to 360 degrees. Using our equation solving skills, we subtract 243 from both sides. That's gone. That gives us our answer of 170 degrees. Next, you're asked to do this one. So again, using your equation solving skills, you do B, add 57 degrees, add 123 degrees, add 123 degrees, all will add up to 360 degrees. Now, when you do finish solving this, when you add all these up, you would have B add, so 123 plus 123 plus 57. That'll be 303 degrees. Equal to 360 degrees. Using your equation solving skills, you subtract 303 from both sides. Your answer will be 57 degrees. But what is the same and what is different about the trapeziums? Well, we know that we have a pair of parallel sides. That's the same. But what's different is that this trapezium, have you noticed that if we were to flip this trapezium over, you would notice that it has the base angles being equal. So we can actually say that this is an isosceles trapezium. Pause the video and answer question 4 in 2 minutes. Assuming you've paused the video and you've answered the question, here are the answers. Well, here you can see that you did not even need to use our fact that the sum of the angles in a quadrilateral is 360 degrees. You could have used the other fact which you learned, that the opposite angles in a quadrilateral are equal. So C is 135 degrees and D is 102 degrees. And then the question was, what do you notice about the opposite angles in a parallelogram? They are equal. Well, pause the video and answer question 5 in 2 minutes. Assuming you've paused the video and you've answered question 5, here are the answers. Let's discuss them. Here you were asked 2 isosceles triangles are joined to form a kite. And here they are. Work out the sizes of the unknown angles. Well, angle W is 38 degrees. Well, how did we get that? Well, if you consider that this is an isosceles triangle that has been put together, we know that the sum of the angles in an isosceles triangle, the sum of the angles in a triangle is 180 degrees. So we know that the angle that should be left will be 180 minus 104, and we need to split what is left, which is 76. So solving the first one, we can say W plus Y plus 104 degrees is equal to 180 degrees. All right. Now we know that W and Y would be the same. So we can simply say, let this be Y. So we can change it to Y, add Y, plus 104 equal to 180 degrees. So sometimes do not let different letters get you confused in solving problems. When you stick to the facts that you know, you can change the letters to maintain the fact that you know. The fact is these are isosceles triangles, so we'll keep the facts the same. So we know that 2y plus 104 will be 180 degrees. Using our equation solving knowledge, we'll subtract 104 from both sides. So we'll have 2y equal to 76 degrees. We divide both sides by 2, and that gives us y equal to 38 and also W equal to 38. If we use the same knowledge to do this one, it's isosceles. We're told that the isosceles triangle, so we use the same approach. So if this is Z and that's X, we can say, well, that can be X as well. Or we can choose to make it Z. It doesn't matter. So say X at 68 degrees is equal to 180 degrees. 2X at 68 degrees is equal to 180 degrees. So if we subtract 68 from both sides, yeah, remember whatever you do to one side of the equation, you have to do it to the other. So 2x will be equal to 180 minus 68, which is equal to 112. And of course, 112 divided by 2. Remember, our aim of solving the equation is to make the x stand on its own so that we can find what it actually is. So x is 56 degrees. Now remember, x is the same as z, and z is the same as x. Why? They are the base angles of an isosceles triangle, which means the base angles must be equal. Is the same for the first case that we did. So that's why we get those answers. Next, you're asked, work out the value of W plus X. You get 94. You just add W and X and then work out that one. What did you notice? Of course, they are equal. Why? Opposite angles of quadrilateral are equal. Pause the video and answer question 6 in 4 minutes. Assuming you've paused the video and you've answered question 6, here are the answers. Let's discuss them. So for these ones, you were asked to work out the sizes of the unknown angles. To work out the sizes of the unknown angles, you can use your equation solving skill. So the angle is R here. So say R, add 91 degrees, add 87 degrees, add 113 degrees, will be equal to 360 degrees. Again, R, add, so 91, add 87, 87, add 113, that would be 291 degrees. So using your equation solving skills, you subtract 291 from both sides. Sorry, that's gone. So 360 minus 291 will give you 69 degrees. Okay? Next, you use your equation solving skill here. Now, what do you notice? These are opposite angles, so you don't even need to do much solving here. If you were asked to give a reason for your answer, you say opposite angles of a quadrilateral are equal. Opposite angles are equal. Okay? Okay. Here is the answer for question 4, C, and D. So let's rub the other one off. Let's discuss questions C and D. All right. For question C, you were asked to work out the sizes of the unknown angles. Notice that we have opposite angles. of the quadrilateral. So they must be equal. So that's 107 degrees. Here, we know that's 90 degrees. So we can use our equation solving skill. So we say U. So I'll just write the equation and I'll let you finish this. So we say U at 61 degrees, add 90 degrees, and we know that would be 90 degrees as well, even though it's not indicated, which will then be equal to 360 degrees. When we finish, you will see that your answer is 119 degrees. Pause the video and answer question 7 in 1 minute. Assuming you've paused the video and you've answered question 7, here is the answer. So you were asked, Dora is drawing a quadrilateral. She says, my quadrilateral has exactly 3 right angles. Is Dora's quadrilateral possible? No, it's not. If she's drawing a quadrilateral and she has 3 right angles, then she's actually drawing a rectangle. All right. So angles in a quadrilateral sum to be 360. So if she has one of them to be 270, that would be 90 degrees left. So that would essentially be a quadrilateral. All right. So her quadrilateral wouldn't be right, except she was just wanting to draw a rectangle. And that brings us to the end of our lesson. So in this lesson, you've learned to apply the facts, 2 facts you've learned in this lesson. That the sum of angles in a quadrilateral sum to 360 degrees, and opposite angles of a quadrilateral are equal. Well done for sticking around and for taking your learning seriously. Until next time, take really good care of yourself, and bye-bye.